How's it going, everyone? Julio Gonzalez here, and today we're going to now finally wrap up this course, the hard part of the asynchronous nature in JavaScript. So today it'll be the last video, and here we're going to see is now how this last keyword that comes from ES7, async and away, actually works behind the scenes. And you may wonder why this is important, or why do we care about that? Because this is now part of the standard, especially if you're going to write JavaScript applications to handle async operations, something that is very, very relevant, not only for the front end, the browser, but also and extremely important for the server, as a way to know how you can consume data and send over that data as a string of data, and now have control about how you're going to generate those data, or how you're going to access through those data, and then how you're going to generate those data. And this course is taught by Will Sentence. Shout out to Will Sentence, the CEO of CodeSmith, which is now a software engineer and machine learning residency headquarters in New York and California, where now he offers several courses on Front-End Master, which is the academy where we are actually learning all of these concepts. So concepts like not only the hard part of the asynchronous in JavaScript, but also the object-oriented programming and the prototype nature, something that we're going to talk about in the next video. But the goal of this course is to now look at how can look at the EX6 and ES7 specification provide you features as a way to now first look at how the asynchronicity works before those spec, and now how can we actually handle this asynchronicity here with these features that the language, the JavaScript, provide for us, as a way to now make sense and be precise when we have to communicate these kind of concepts to technical people or not, business people, designers, managers, PMs, shareholders, your clients, you name it, right? That's also one of the reasons why, especially this skill set, not only your analytical skill, which is very, very important, but also your technical communication, which is based on your approach. Can I implement that from what you explained that? So in other words, so can I implement your solutions based on your explanations? And that is something that is valuable. Even though that I get rejected a lot of the time for several companies when they say, okay, your technical skill is also not what we need to. You need to continue to improve your technical skill, which is something that I'm going to do, but also your communication skills. So again, this is a combination that in any relevant field, I will argue that you should do, whether it's a CPA or lawyers, especially lawyers. So lawyers, physicians, engineers, and here in the software engineer, because most of the time we are silent in front of the computer, we need to actually do that as a way to now, when we have to explain that again to other people, business people, designers, PM, shareholders, your clients, your college, you can do that in the most precise, direct possible way. Because now one of the roles, or one of the reasons of being a senior developer, or be a senior computer science, or any senior citizens, is that you can make those abstractions meaningful to others. And that's something that resonates with me a lot. And the reason why actually I taking notes out of this course, you're not gonna see that because of course I don't want to receive any flag from YouTube to say, hey, you, okay, good that you're actually learning, but I already receive a flag from the legal department from the master, where they say, okay, good, you can record our videos, okay, you can record yourself learning, but don't put our videos there. We don't allow you to do that. So that's the reason why I'm actually taking notes out of that. In this course, all right, or as a way to now describe is what are the skill set that you as an individual should have, especially when you have to offer that to a company or to someone else. It's like, specifically in this case, in the profession, it's like your analytical skills, how is your thinking process, your technical communications. If you find any roadblock, why, in what is this roadblock? Can you describe that? As well as the follow good engineering practice, improve your soft skills. It's like, okay, be empathetic, be also patient with yourself and with others along the way. And lastly, but not least, is the domain specific knowledge, in our case with JavaScript. So this course is made of six sections, that's right. Introduction, asynchronicity, promise, iterators, and generators. I mean, I don't know how to count, it seems, because it's 5. But yeah, this is the introduction, okay? And we're gonna pass through all of this briefly, and then we finally going to implement our generator and how that actually works with the async and await syntax, and what is the async and await syntax is actually doing for us. Okay, so first thing first, understand what are the JavaScript fundamentals. Okay, that is the threat of execution, at least those fundamentals that are relevant for the asynchronicity, the threat of execution, the local variable or the global variable environment, and the function execution content, which contains its own threat of execution, and the function variable environment, the call stack as a way to keep track at which function we are currently evaluating, at which line in the code we are currently evaluating. Okay, and also a nice interesting bonus features, that is the closure. So now with closures here, we have now is this nice little bonus, as I mentioned, feature that it provide us is a persistent storage of our lexical environment, the outer lexical environment, or in other words, it allows when you return a functions from another function, even though that is those functions that you're returning are inside of an object, you are effectively creating is a closures, which means that, hey, now this function can have access to the outer lexical environment, to the outer variables, the variables that are defined outside of this functions scope. So that's very powerful, because not only that, it also allows you to store that persistently, which means that you can use this these closures for actually doing things like running or creating is function that will run once, like once method. So for example, if you want to run is the congratulation at the end of the game, it's actually allow you to do that. Hey, I want you to run these functions once, this condition, only that. We also have is the memorize, which now, based on a given input, we store its result, and we return that. So next time when we receive the same input, instead of actually perform the computation, we want is to now return is the result. So this catch versions, that's actually something powerful, because not only for the Fibonacci, but for when you don't want to actually re-render certain components, or when you want to actually compute the things once, okay, while catching its results, is actually something important, because it's saving you computational time, and time is the most important asset that a computer science have, and also as an individual. But in any case, and also it allows us is to some other patterns, like the model pattern, where we can define is all of our also your functionality or variables, and then provide this model way using also the immediately invoked function expression. So providing now this model that avoid us to pollute the global namespace, and when we want to access to those models, we do that by running certain functions. So this is the model pattern that unlocks, and which is the model actually is working that CommonJS is using behind the scenes. Also, we have another patterns, which is like the iterators and generators. Okay, iterators is as a way to know this way of thinking of how we access to our data. Instead of being imperative to do that, we just now wants to get these elements one at a time per sequence, okay, and using now this particular pattern, the closures allow us to do that. When you define is some inner logic there, iterative logic, and how, because with iterators it requires you to write, it requires careful programming, because you have to manage these inner states. Now with generators, it allows us now is to provide convenient functions as a way to produce, or consume is items in a collections. So now with generators, we have the ability is to not only send or to access or to pass data, but in other words, is to generate data as flow of control. Generate data one after the another. We have control flow of that. But also we can now actually is pass data. Something known as these functions can be seen as data consumptions and data producers. So all of these concepts unlocks now this async and await syntax that allow us is to write asynchronous operations that will take some time in the future to be completed, and when that is available on the next line in a thread of execution, we get that data there. And I think this is the missing part, especially when you need to explain how all of these things work. And I think that's very, very, very useful. So this is the introduction. Then we look at the asynchronous in JavaScript as a way to look at how now before the EXs do we handle that. So because JavaScript doesn't handle is async operations, is their host is the browser that it provides this functionality, these facade functions from these facade functions like the set timeout all right, in the case of the browser, or set timeout in the case of the set timeout in the case of the browser, set timeout in the case of the server, okay? And the way how they work is by receiving is a callback, or we are injecting is this function that when that time is over, we're gonna receive that back into the JavaScript world. How does it work? By using is the callback queue as a way to now adding all of this callbacks, and when the call stack is empty in the JavaScript world, the event loop, which is this mechanism, we're gonna first ask, hey, if the call stack is empty, yes, all right, now let me pass whatever I got in the callback and send that to the call stack. So now in JavaScript, okay, it can detect that and now evaluate that. So after that, pop off out of the call stack. This process is something beautiful once you understand that, but it introduces a particular problem, which is it lack of readability. Because anytime you now write is a callback, and the data that you get or this async data that depend on another async data, and you have now this change of async data dependency, that's the reason why we have all of these callbacks known as the pyramid of doom, or the callback hell. So because of that, now that we are able to look at a new alternative using promise, which is now provide us for the language in ES6, to say, hey, this is now the way of how we're going to handle is async operations. So this is an object that is creating on the JavaScript with the value as well as the state to indicate that, hey, this is pending initially, and when is that resolved, using a set timeout, which is something that you have much fine control, or when a such function actually return that, like the fetch or read a file in the case of the node. So when that such function actually be able to resolve that, all right, what'll be the callbacks, the function you want me to run? And if something went wrong, hey, what is the code that I want you to run? What are the instructions that I want you to run? So that's what we have now is this hidden property called unfulfilled. If we can take a look at the ECMAScript, the ECMAScript here. The ECMAScript here. The ECMA, the promise object, okay? And it's interesting because when we talk about the promise object, it enters in the control flow or the control abstract options, okay? So this is now the property of the promise instance, that you got a state, you got the value or the result. You have now a list of fulfill reactions or a list of reject reactions. In other words, the .then or the .catch. Hey, when this promise is resolved, I want you to now run this set of functions. I want you to run this callback here. If not, well, or if something went wrong, I want you to now read this callback under the catch method. So what you're doing with the .then and the .catch is actually appending is the function that you want to do when something goes wrong, or when you get what you want, when you get a success response. So this is now how can we handle this? And when that value, okay, is updated, when that result is updated by the host, okay, whether it is on the browser or on the server, all right, now we can is using the event loop and the micro task queue, which is now another feature that provide the JavaScript engine, is that hey, now we can have a new queue, micro task queue, which has more priority than the callback queue. And when the call stack is empty, the event loop is going to evaluate the micro task queue, grab all of this micro task and pass that to the callback queue until exhaustion. So this is one of the things to consider when you are adding a lot of this micro task queue to the micro task queue or to the job queue, because it will never reach to the callback queue if you're constantly adding a micro task. And you can do that anytime you run a promise inside of another promise, inside of another promise, and so on and so on and so forth. This is just one use case. So, all right. With that, that now we know the mechanism and how these things work behind the scene, and now how the event loop in Node actually works by saying, hey, we got all of these different phases of the event loop that actually are handling is specific input and output, specific async operations, specific events that are relevant when we are running our server. First is a timer. Second is a pending callback. So for example, when handling is TCP error connections, and the TCP is the layer 4 of the OC model, that this is the way of how now different computer hardware and software computer systems can talk to each other and share data. The OC stands for Open Standards Interconnection. OC model. Okay. Yep. The open systems interconnection. Sorry. Open system interconnection. All right. So the layer 4, which is the transport layer, which is indicate which kind of protocol we are going to use as a way to send this data. Okay. Whether it is connection based, TCP, so I need to wait for the other person to reply with a handshake, okay, and guarantee that the other person is, or the other computer system is on the other side. Or do I need to, or I can send this data, and whoever is receiving that, well, they will receive this chunk of data if they're there or not. And the OC model has these different layers as a way to now transform all of our data from the application, from the user level, when we want to perform is the network operations, to the presentation layer to say, hey, what will be the format in where we're going to send this, as well as are we going to send encrypted, are we going to send, we're going to compress this data. Then the season that established is the way of how now you're going to which port you're going to send this data. The transport layer, which indicates which protocol we're actually going to establish this way of sending data. TCP, UDP. There is also another protocol that Google developed, like Quick, if I recall that right. Then we have is now how this data is going to go over through all of these physical devices, okay, which is what will be the route, what will be the physical path that this data will have to take, which is the network layer, when you define is the IP, the data link that indicate what will be the format of this data will be sent, which means you have much more control about okay, how I'm going to send the data from one device to the closest one. And lastly is the physical, which is we're going now to actually, now that we got all of this data, all right, we're going now to send this raw string data over any physical medium, okay? Whether it's cable or internet or satellite. That's interesting because now you can have a lot of perspective of what's going on behind the scenes and how now the event loop, by providing is this callback functions, okay, or these phases to evaluate different specific and useful events that happen in your server. All right. So the timers, pending callbacks, you have is idle and prepare. Then you go to poll, where now in poll is where it's going to set the data connections and the pooling. Then you have is another phase, which is the check. This is when you can use is the set immediate as a way to add queues or add tasks to this particular phase. And lastly is close callbacks as a way to say, hey, what you gonna do when you destroy a socket, or when you close or when you end a connection here. So these different phases, each one of them, you can think act as a callback queue that before going to the next one, the event loop usually will evaluate whatever is at that phase, whatever callback it has at that phase, until exhaustions before going to the next one. Certain rules apply, okay, but that's like the general rule, okay. So with that, okay, now when we go back here as a way to deal with promises in the browser, and the reason of now why in the EX7 we have this feature called async and await as a way to make sense of what is doing behind the scenes, we need to first look at what is Iterator. And this Iterator concept is just a way of how can we now access data as sequence of data by now recognize that most of the time when we're working with our data, we actually is selecting is the, most of the time when we're working with our data, we are working is with collections of data, or collections of states or objects, whether it's an array or map or set, linked list, tree. So wouldn't it be nice to have a way of anytime we run a function, we get the first element, the next function, the second one, the next function, the next one, and so on and so forth. So we have now this particular functions that anytime that we hit, we get the next element as a way to have access to these collections of data as sequence. So now, because of this particular approach, where we don't need actually to know how to write is, because we don't need to actually know how to write is the iterative logic, okay? But it's important to know how to do that in an imperative way, because this is how now previously we do all of this kind of thing in an imperative way, okay? Then we look at how can we do that using a for loop, okay? When you have the initializator, which is looping, part of the feature of JavaScript, like the vars, let, cons. What are the main use cases between var, let, and cons? Something that we would like to recap in other videos. TLDR is that VAG is scope is function scope, where now let and cons is block scope, okay? And now how you, by using a for loop, all right, did I lose my shit? By using a for loop, okay, you will now have is by using is a for loop, you can now see how you can access to your data in an imperative way. So using is the for loop here as it is. So the for loop, okay. So this is the initializer, the condition less than some sort of array length. Most of the time is like this, and then the after through. So what you're gonna do after that is usually is increment the length, so you can go to evaluate this block of code for this time. Okay, anytime we win this, you're going to evaluate this, and we're gonna move ourselves to the next position. So for example, if we define the array here, okay, as cons here, let me define this as a let, so I can now modify this value later and say 1 2 3 1 1 2 3 1 2 3 4 5. Okay, so what I'm gonna do is to now in this block scope define is an iterative looping, iterative algorithm. So what you want to do anytime that you are in the first position, and then you move on to the next one and to do this in the second position, into the next one and to move that, and then what you're going to do in the third position, and the 4 and the 5. This particular topic is something important to recognize, because this is what actually this is the kind of problems we are companies, okay, and the reason why programming actually became so useful is because you're not only solving is scalability problems, okay, because exactly, so you're not only is iterating mindlessly through this sort of collections, okay, you are now is actually is finding ways to now how you can be efficient and effective when you want to, for example, go to a shopping list. Okay, so hey, when you now this I got this shopping list, okay, with all of these ingredients, and I want you to now send to someone that can do that for me. Of course, you have to pay for that. So now you get more time to do other stuff. Well, this kind of persons actually is now that person can focus on going through all of these elements without you having to intervene there. In other words, one of the reasons of looking at these iterative protocols is because it's recognized that as we grow up, we initially don't have a lot of stuff, or we don't have too much responsibility as it is, right? The only responsibility that we have is initially is none. Our parents are responsible for us. But as we grow up, we're now starting to get more responsibility. We're starting to have say, okay, I need to know how to maintain my body. I need to how to maintain my physical being, how to brush my teeth, how to eat properly, how to now keep learning, how to now find ways to provide my service or to earn money, as well as discovering myself or what I want to do in this life. So there are a lot of this responsibility that you're gonna get, and you're gonna receive that at once. And the idea is that you can do that in a progressive way. Okay? So why this is important? Because now when you want to set a business, okay, or when you want to, as I mentioned before, when you want to do things that you know that are repetitive, okay, and you need to actually do something in there. So for example, if any of you, I will invite you to hit the gym. That's quite fantastic. But if you do that, if you have now a program of what to do Monday to Friday at the gym, so you don't need to worry about what you're gonna do. You already know what to do, and that leads you to perhaps focus on sharing with other people, exchange or talking at the gym. So the idea here is that once you're able to automate a process for an outcome, which is in our case, it can be, well, I'm gonna hit the gym for 3 months to lose to, sorry, to lose, let's say 20 pounds, okay, 50 pounds, 10, 50, 20 pounds, okay. Once you reach that goal, what you do after that is up to you. But the reason of doing how we can now iterate through this is a way to now look at a particular example and how can we apply that here, okay, is that if you think that each one of those are days of the week, okay, and you want to now do something on each one of those days, now it makes sense for these for loops to exist, okay, and for this construct that the language provides. So we don't actually have to do that for ourselves manually. So we don't have to, hey, do this. No, it's not the actual language going to say, hey, I'm going to do this algorithm, this iterate algorithm for you, and that'll be great. Okay, and after that, bam, it's over. So All right. Yeah. There we go. He went with oh my god. Oh shit. Oh nee. Oh nee. Anyway. Oh, oh nee. Okay. So that's the reason why this is important. And when I look, the first time I look at 4, it's like, Jesus. It's like that thing is something that didn't stick in my mind. Pedagogy is something important. Oh my god. Anyway, pedagogy is something important, my friend. Very, very, very important. Okay, so that's the reason why we are defining here for loops and the way of how we can now do a transformation or perform some instructions is inside of this block where you're gonna say, hey, I want you to do this, okay? I want you to run this set of instructions for any time we are now going from here, from 0 to the array of length. So we can imagine that going into that door, open up, hey, there is a value here, I'm going to do this set of things, and then I'm going up now, close the door, move on to the next door, and do the same. Hey, retrieve the value, take a look at it, do the inspection, do we got anything here? Run the instructions, yes, close the door, move on to the next one, and so on and so forth. So this is a good analogy, or I will argue that this is a good analogy when you actually now explain this in simple terms. Okay? So because this is a very imperative way to do this, you have to write this manually, and you have to say how you're going to access to the data, which is a task in itself. The Iterator protocol say, hey, instead of actually us worrying about how we're going to access to the data, it's writing is the logic to access the data. Wouldn't be better to actually have these functions at any time we run that, we get the first element. We run that again, we get the next element. We run that again, we get this element, and so on and so forth. So iterators now allows us a convenient way to say, okay, anytime we want to iterate through these collections, okay, we would like now to use is the Iterator protocol. And the Iterator protocol, or the iterative protocol, it means that it's made of 2 parts. First, something that I call is the label, which is, hey, this is to recognize that I am an iterable object, that I'm something that is a collection, that is iterable. Okay, and to do that, in the case of JavaScript, well, you in that array, you have to now under the prototype, which is something that anytime you create is an array, it has now an object, which object has the prototype in there. So if you take a look at this as a way to console log this, this is what in JavaScript all objects have this prototype. Jesus, prototype objects. It's undefined initially. All right. Interesting. Okay. Oh, because let object. empty object. Okay, but if you define this as a function, okay. Lexical expressions, statement, functions, and classes, script, and models. Object prototype. Oh my god. Okay, it's because in the documentation they oh my shit. In the end. Okay, in the docs they call this prototype as the reference. Jesus freaking Christ. As the reference to that. Okay, as the reference to that. Object.assign, .create, define prototype, property, define properties. Exactly, static method and instance method. They are deprecated, and I love it. Object prototype.constructor. But see that you got that prototype. You of course have that prototype. You of course have that prototype. But it's because on the prototype. So this prototype is what allows you to define is this prototype, property of the object instance. Object instance has no special property beyond those that are inherited from the object prototype here. Okay, it has the proto. Okay. So prototype here is that it can access to the constructor and the prototype. But now when you take a look at the functions, when you take a look at the function, it actually have a function prototype here. Property data, property of function instant is used when the function is used as a constructor with the new operator. It will become the new object's prototype. But it's a standard built-in instance method, exactly, and instance property. So once you want, for example, when you want, for example, is now create an object, okay, with that iterative logic, all right. For example, exactly, this is something important here. When you want to create now an object with that iterative logic that we mentioned. So for example, hey, I want you now to know how the array or the collection array iterator, okay, which is a function that initially is going to receive an array. What you can now have is this array inside of your function constructor, okay, and then we would like you now to define is the iterator protocol as a way to describe, hey, this is now anytime we want to iterate through this object, I would like you to now do that using this particular protocol. First is the iterable protocol. That means that, hey, this object, I call this the label, which is, hey, this label that I get in this object called the symbol.iterator is indicator to whoever wants to consume me using the iterable protocol. You can, and this is the standard when I'm going to generate the object, the return, the expected return. Following is the iterator protocol. So this is the iteratable, okay, as a way to indicate, as a way to describe is that this is the label that this object will have, and this is the logic that I want you to run when you iterate through me. And the way I'm going to respond to anytime you iterate through me is with the iterator protocol. So how we can translate all of that here? By now saying the array iterator prototype, okay, prototype to the symbol, which is a special type in JavaScript, iterator, as a way to say, hey, now this is the signature that is indicating to other to the for of syntax, or whoever can consume now this collection of values. Following is the iterator protocol. Is like, all right, this is what I want you to do. First is to say, well, let me define now the index here as 0. Okay, and then define a function called next here, where this function is not going to receive anything right now. It's just going to actually is define the logic to get the first element, and then the second one, and then the second one. This iterative approach. So by saying is that initially we want to get the value, okay, which is this dot array in the 0 position, okay, and then increment that. So if, for example, now so if now the index is less than the this dot array dot length, okay, I want you to now is, okay, I want you to now here is to not only increment the value, but also returns is an object from this function that will match the signature of the iterator protocol, of the way of how this syntax needs to be consumed. This is the protocol of this is the standard of how I'm going to send the data. This is the object, that is the value, followed by the DOM. Initially is false, and then, all right, so if we actually reach to the end, we say, hey, it's going to return now is the value, right, and passes it down as true, indicating we're done. So this is the way of how can we define is this logic, okay, anytime we want to access, or anytime someone wants to consume, someone wants to iterate through this object, okay, expression expected, wait, what, expression expected, oh, okay, Let me refresh here. There you get it. So now, all right, that we get this, when we, for example, define is words, or we can say is characters. Okay. When we say characters from words, and we call now that array iterator, and we pass the value here. You say, hey, lorem ipsum, and now we run that function here with the next method as it is. We need to actually is call it with the new keyword as a way to actually now allow us to have access to the property and method for the functions and access to all of, as a way to allow us to build our objects. I think this is not going to work. In fact, it's gonna complain about it. Yeah, it's gonna complain about it. All right. New array iterator. And then we say, okay, I would like you to give me is the character from dot next. We are not returning is a dot next function. That's it. We're not returning is the next function as an object. Now this will work as expected. We say is the character from words. So characters from words. I want you to get me is the next here. Okay. So character from words. So now, when I want to be consumed from this, okay, when I want to now iterate or apply some iteration using now this syntax for each value of the iterable, in this case the array iterator, as it is, the character from words, I want you to now is, oh my god, that makes a lot of sense. Okay, I didn't define that properly. Is that index, and index. Okay. Now this is supposed to work as expected. So what we say is now the character dot next. We want us to run this function. Okay. Anytime we pass through all of these elements, where we say now using the for syntax to say, hey, any value that we get here of the character from words oh my god. No, it's okay, it's okay. Thanks to the language that actually is complaining here. Okay. So now when we want to actually iterate through this, okay, by saying here is the next, that's the function that we want to run. But when we are inside of the for here, so when we get the value of when we get the value of when we get the value of exactly. So when we get the value of iterators, that's right. So when we get the value of iterator for counts value of the iterator, which is character from words, okay, we want now is to print is the value for that. It tells me that this arrow is not defined. That the array is undefined. That's quite interesting. This dot array is defined here. Let me reevaluate this. Really? This array, okay. And then array iterator, that's right, prototype, symbol.iterator, it will be a function, right, that anytime we get here in the next, we will like, oh, it's because that makes awesome. This is this scope, man. This is the this scope in action. Okay. This is now the this scope in action. It say, hey, I don't recognize what is on the left side, so this will actually correct that behavior. And now, when we are being able to say, hey, good, when I now want to iterate through this, comes the value of the characters from words, all right, and now I want to get the value from this. As you can see, we actually is getting all of this value for that, right? Loading, ipsum, so give me all of this as streams of data. And now not only iterators but also generators, okay, like this, okay. What's defined is the gen object. It's also generator. Generators can now allow us is to, well, produce flows of data by saying yield 5, then yield 6, okay. We like to define that in a more broad sense, okay, like, and then you say yield 7, and instead to us to actually have to tell what we are, what is this inner state, instead of we actually indicating what will be the inner state, this generator functions allows to define is a iterative algorithm by writing a function whose execution is not continuous. In other words, that you're going to get into the execution context, yield that out, yield that statement, go get out, okay. And if any time, and if someone actually calls you again, go into the execution context, evaluate it until the next yield, kick out of the function execution context, and that's it. So this back and forward, or this inward and outward of this function is something that is manually, so you have now much more manual control about that, okay.
And here we can say, hey, when you want to actually stop the execution, which means when that you say, hey, this is the end of this generator function, you use the return keyword for that. Say 8, right? So now when we want to iterate through this, which is generators are a special type of iterators, by using this a for of loop, and say, hey, I want you to get the value of this, okay, which is quite interesting. When I want to get the value of this, for counts value of, all right. Exactly. So for counts value of. Like so. Yeah, for counts value of the generator object. Okay. So now we are able to consume from that. Now we are now able to consume from this generator. Gen object is not iterable. That's interesting. Really? Generator function. Yep. Okay, this is the way how you do that. Oh, because I need to call it. Of course, because I need to call this object. So now it can actually, when you run this, it will generate that generator object, which is a special type of object. So now, by running this, we can actually get is this 5, 7, 8, but we'll never get the 8. So this is when you say stop the execution. So that's one of the great things of this, is that now with iterators and generators allow us this way of how we can access to our data. And in the case of generator is by writing is a functions where we can specify is the iterative logic of the writing a function whose execution is not continuous, which is anytime I run this function, I want to get into this function generator, evaluate the statement until you yield an outcome, get that outcome from that, you follow this particular shape, okay, of the next object, which contains the value as well as the DOM, okay. So if we actually want to take a look at that again, you say, hey, we get only is the value. The whole point of this is that we are now able is to find a way. So with the coupling is the way of how we access our data, to what we're gonna do with our data. Because at the end of the day, that's exactly what the software developers actually want to and needs to. And that is hey, this is now how we decouple of how to do to what we're gonna do, what to do with. And that's something interesting, because now that lead us is to understand is that how the async and await promise works behind the scenes, okay? And how we can now, by using is a generator, we can now have the ability is to say something like this, which is, hey, I want you to now here is to generate a function. Let me actually write this function here. I want you to now is to generate is a function here. Function do when data receive. Function do when data receive. Okay. First, I would like to define is the function is the generator function. Okay. So this generator function, which will be, let's going to call this create flow. Okay, this generator function, what it's going to do is, well, define how we're going to yield the outcomes. Or in other words, first we're going to define is a data here, where we're going to evaluate. First, we want is to actually fetch some data from some public API. Okay, let's say public API is here. Okay, public API from the docs fact. Okay, this is doc facts as it is. Okay, cool. Doc fact API, but I want is something that doesn't have any course or authentication. Cat facts. Okay, cat facts. Docs. Oh, it has a course. Okay, that'll work. That'll definitely work. That'll definitely work. So with this, what we're gonna do is like I want you to now call to this, okay, and say something and do something for me, which is when we get into this generators, I want you to yield this, okay. So evaluate this expression first. So the fetch function the fetch function will, in this case, yield is a promise object where the response, when it's resolved as a response object, okay. And then the next time I call this function, I want you to now assign that to the data, okay. So then we can now actually just console log the data. Console log the data. Okay. And because this actually return is a promise for that data dot then, we want this to now is to since the value here is a doc image, okay, I want you to now is console the data doc image that we received from, okay. So far so good, because now what we can do here is once we describe this generator, this is the thing that I want you to do, okay. When I run these functions, hey, I want you to now perform this fetch operations, which is creating a promise objects, and behind the scene is actually going to evaluate when that resolve is resolved, or when that promise is resolved or rejected, and then update the value and add now the callbacks, or in this case whatever callback we pass to the dot then to the micro task queue. So the event loop now will going to evaluate that micro task queue as long as it has complete all of the tasks in the JavaScript. In other words, as long as there's nothing on the call stack, and then going to pass that with the proper data. So that's exactly what we're doing here. So by defining is this function, and by saying, hey, once you get that data, okay, in another function like this is what I want you to do. For example, function or this is now the do when data receive. It's like do when data receive, okay, which is the data. We can make sure that we get the data, and when we get that data, now it is time to call is the generator, which is since we haven't created a generator right now, we're going to do that by Well, first define is the generator here. So return next element, return next element here, and say, hey, I want you to now create this generator. So this, what it's going to do is, the first time is to actually get you the generator object. Okay, so when we get this data, all right, now I want you to, after we run that the first time with next, I want you now is to run here is, yeah, I want you to now run this. Exactly, I want you to now run this, which is quite interesting here. So I want you to know now the first time the data, what you're gonna get is the future data. Okay, and only now that we get, since our data that we're gonna receive is this promise, when we get that data, now I want you to trigger is the generator, which is the do while data receive, when we are going to pass is the data as it is, and it's inside of it we want us to actually call our generator that we create, which is return next element dot next, and we're gonna pass the data to that. So this is something interesting that it's going to do here, because first you are creating is a generator to say, hey, this is what I want to yield. I want to yield this promise, okay? And then yeah, I want to now define is this generator to yield this. Then going to run that generator function, okay? That is going to return me this is the promise, and when now I get that data available, okay, under the dot then, I want you to now trigger is the generator function for us, okay, as a way to now pass the generator data, so we can get the data and we can see the data as it is. So all of this inward and outwards that's going on here. Future data is not a function. Return next element here. Future data then is not a function, which to me is quite interesting. It's supposed to be. No, this is function. I want you to yield this. Oh no. Now, and the next time we're gonna get is the data here. Exactly. And it say future data return next element dot next. Future data dot then is not a function. That's quite interesting, because the truth is that it's supposed to be that, because we're returning is a promise. You say object of value here. Exactly. But it's a feature data dot then is not a function. This is in fact is returning us a function there. Oh, I get it. Because the shape of how now the generator function is actually returning that, and that is the dot value. Okay, remember that this next function is returning is an object that contains the value as well as done. And now we get that. Holy moly. And we print that data after that. So we now are effectively created is an async and await behavior. Okay, let me think about this. It is a holiday weekend here in Canada, and on Thursday I will be on vacation for a little while. A little vacation. I'll be on vacation a little while, but I keep this in mind. I appreciate the offer. Oh. Weekend here in Canada. Oh, of course. Yeah, summertime. Go get it. Go get it, Patrick. Yeah, go get it, Patrick. Summertime, go get it, Patrick. you more you more than I know how depressing is the winter and how fast the summer fly and how fast the summer goes by. Exactly, it's 1,000. Go get it, Patrick. You more than I know how depressing is the winter and how fast the summer goes by. Enjoy it. It responds body, headers. Yeah, body, headers, that kind of thing. Yeah, response, body, headers. That's pretty interesting, man. That's pretty interesting. That's pretty interesting. Future data dot value dot then, exactly. And this is the way how can we create this async and await syntax. Holy moly. That's pretty wild. So hard part of async here. That's a senior engineering question. That's completely a senior engineering question. Async await.js. Holy moly. That's interesting. That's very, 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 very interesting. Add async await with generators. Holy moly, bro. So this is now actually interesting. And finally, first enjoy your summer. Chill, man. First enjoy your summer. And relax. Holy fuck. That's pretty interesting, bro. It's like, that's pretty interesting. That's now let's take a look here. Now let's take a look at how can we implement the async and await syntax and how that is working behind the scenes.
Dives us back into create flow execution context. We manually do so using our next method call, which was triggered by the triggering of our do when data received callback that was attached to our future data promise object. But this flow inwards and outwards and gets complex.
It's complex.
And so JavaScript gives us a async function that's going to automate that process of going back into the create flow function. it's going to say, don't worry, we don't have to trigger going back into it. Instead, we're going to go automatically back into it. We're going to pass the response object value back in as the evaluated result of the yield expression and store that straight in data. It's going to simplify all of this code for us with the help of the new async functions. Async await simplifies all of this and finally cleans up our inversion of control problem of callbacks. We're going to see that now, for the first time.
Exactly, solves the inversion of control of promise of callbacks, because when you write that particular solution there, you say, all right, it makes a lot of sense now of how now by using this generator as a way to create these functions, this initial function, right? This initial function that, this initial function, this generator function, this function that's going to yield is an async operation, in this case, a promise of that. So when we now run that, which means that by the time that we run that generator function, it goes into that function execution, yields that get out, return of the promise object from the evaluation of the yield expression, and now that we get the promise, when that promise is resolved, we are now going is to trigger is the next we're gonna now is trigger we're gonna now is to run is the next sequence of our generators that actually contains is the data. And this process of inwards and backwards, this process is complex. So the async generator, actually, or the async and await syntax, is abstracting this complexity, making it easy for us when it comes to handling this.
Define a task to be done beyond our control much later on. Instead, we're going to go into Create Flow, set up some work, set up a task that takes a long time. That is our speaking to the web browser that speaks to the internet, gets our tweet, 200 milliseconds brings it back. And then we're going to somehow get back into Create Flow to continue running our code sequentially. No need for a triggered function on the promise resolution. Instead, we auto-trigger the resumption of the Create Flow execution. That functionality is still added to the micro-task queue, though. All right, so here we go. Blessing, line 1, what are we doing?
We're going to declare an async function called create flow.
Excellent. Create Flow is defined. It is a function. It is an a brand new type of function, an asynchronous function. Good. Line 2, Blessing.
We're going to be invoking the function we just created, which is create flow.
Excellent. We're going to invoke Create Flow, and we are going to immediately enter its execution context.
In the execution context.
Immediately enter its execution context. There it is. And what is the first thing, Blessing, that it tells us to do in this execution context? Let's say at about 1 millisecond.
It's first evaluating its parameters, but because we don't have parameters,
So about 1 millisecond,
well, no
we hit our
problem.
console log.
It's going to now evaluate the threads of
So we do
execution,
go into
which is now
just
console
like
log
our
here.
generator function we have to trigger going into using the next method that the call to the generator function returned out, the next method on that object. Instead, we're going to go into it directly ourselves, just by calling it. So the first thing we do is indeed a console log of the string me first. Perfect. And in our memory, what is the next line of code, Blessing, that we are going to encounter?
We declare a constant data.
So with the
There it is.
constant
And for now,
data.
undefined, exactly. So we set data is going to be the evaluated result of that expression on the right-hand side. So there it is on the right-hand side, we say await, and then fetch, the return of our wonderful, our final call to our fetch facade function, a two-pronged function that in JavaScript returns out a what, Blessing?
A promise object.
A promise object.
But it also spins
Exactly.
work in
It's actually
the web browser
actually
itself. So
handling
let's
is
do
working in the
JavaScript piece
background.
first.
And in this
We are
case
going
on
to
the
learn
browser, or it
out
can be on
a
the server
promise
using
object,
Node,
just as Blessing said,
which is
with
now
two
passing
important
that
properties, but two important
to
properties.
that
Value
control as a way to
and
handle
fulfillment,
this
which is an empty
network
array.
operations.
Both right
In the
now
case of the
haven't been interested
Node,
yet. The value is going to be auto
that'll be
filled in with
evaluated
whatever comes back from the web browser, features,
in
background
the
work, and
poll.
your fulfillment array. Well, we'll see what that's going to do here. Good. But, oh, and that object here, we're going to hold it here for now. But in the web browser, what are we spinning up? We are spinning up the background feature XHR. There it is, XHR is spun up, and it has some important properties. The URL, twitter.com, the path, /will/1, something like whatever it is, and the type of request we're making, and it's a GET request. And we are sending off an HTTP, that's the H in the XHR, HTTP message off to Twitter itself, their server. There it is, the beautiful Twitter server. And is it, at this moment, at about 1 millisecond, Blessing, is it complete yet?
No.
It is not. But when that data comes back, it'll be complete. What do we want to update on the completion? We want to update this value property. Now, we have not assigned this object to any particular place. It's just a position in memory. So we know that we're referring to this object we defined, its value property. That's what we're going to update. We didn't give it a label in JavaScript, but the web browser knows where that object is stored, and that's the value property it's going to update. Okay, perfect. Good. And now the all-powerful await is going to throw us out of the create flow execution context.
So the await is going to throw out
value property. That's what we're going to update. We didn't give it a label in JavaScript, but the web browser knows. And now of the create flow execution context. Have a very clean eye. I'm going to throw that out of our create flow execution context, where we are going to encounter context. Have a very clean eye. I'm going to throw it out of our create flow execution context.
Here we are evaluating. Here we are evaluating is the create flow function. But now what we're going to do exactly, but now what we are actually evaluating is where we are actually evaluating here is come on, goddamn. Get out of here, man. What is the other function? That's right. But here what we are evaluating here is this function. Okay. Here we are evaluating is a create flow function as a diagram. Now the async and await. Okay. The async and await. Yeah, the async and await exercise example, where here we are now is defining this particular. This is the async and await. This is the async and await generator. Exactly, generator. That's right. And then we have going to define is the async and await .js. which is, well, actually defined as the async function of create flow. All right, where here we are saying, all right, let me now define is that particularly it's like me first. So hey, I'm going to be evaluated here, so me first. Okay, and then do something like this. Data, and I'm going to await, which is a powerful keyword here. And we take a look at the await. Right now you're not able to see what I'm doing, but you will. Which is, I am writing a function here. So the await here, the await operator is used to wait for a promise. Is used to wait for a promise and get its fulfillment value, and it can only be used inside of an async function. And what we talk about is the async function, or a top level of a model. Okay, of a model. In the case you're going to use this with the or in the top level in the model. But these async functions declarations create a binding of a new async functions to a given name, and a binding is just this association between the identifier, a label, and its value. In this case, is with the new async functions to a given name. The exactly async functions declaration creates a binding. Okay, the await keyword is permitted within the function body, enabling asynchronous promise-based behavior to be written in a cleaner styles and avoiding the need to explicitly configuring promise change. You can also define async function using the async function expression. It doesn't tell you what it's doing behind the scenes, but what it's telling you is that what it does. Okay, it doesn't tell you how it works, it tells you what it does. Is this ability to now allow you to write is asynchronous operations promise-based, and I allow you to enabling asynchronous promise-based behavior to be written in a cleaner way, pretty much like JavaScript evaluate statement, one after the another, and that's super important. That's super great. Okay. All right. Okay. So async functions like this, and async functions like that, and async functions like this. So this async function can receive any parameter, and then evaluate this statement. The description. An async function's declarations create an async function object, as it is. Okay. An async function. And an async function object provides methods for async functions. In JavaScript, every async function is actually an async function object. That's interesting. That's interesting. Know that async function is not a global object. It can be obtained with the following code. Async function is async functions dot constructor. So async function is a subclass of function. Now all of this concept of subclassing and that kind of thing started to make a lot of sense. So we to cover is specific challenge that the language is now allowing to do, which is how we organize our code, how we organize data and its relevant functionality into one single bundle, the object programming, as well as now how can we handle this async operations. You know, how can we talk to a server? How can we now read files and wait until that is completed. And this open up a new powerful type of applications that we can work on. This modern JavaScript applications. Jesus Christ. Okay. Holy moly. Async function is a subclass of function. Constructor. Async function. Instance property also inherit instance property from its parent function. These properties are defined on async function.prototype. Okay, because after all, it's a subclass of the function object, and the function is a special type of object which can be called, and then you can define its functionality inside of the prototype. Okay. And you have this instance. Okay, that's quite interesting. It has this prototype to string tag. This initial value, as it's like a label where you say, "Hey, I'm an async function," and this is the async constructor, the async function constructor. The async function object provide method for async functions when we're talking about this. Okay. So now an async function declaration created an async function object, which is a subclass of the object. Each time when an async function is called, it returns a new promise. That's right. Okay, each time when an async function is called, it returns a new promise which will be resolved. Oh, remember, each time when an async function is called, it returns a new promise which will be resolved with the value returning by the async function, or reject with an exception on caught with the within the async function. Async function can contain 0 or more await expressions. Await expression make promise returning functions behave as though they are synchronous by suspending execution context until return promised. If fulfilled or rejected, wait, what? Await, exactly. The await keyword is an operator used to wait for a promise and get its fulfillment value. Where now in the case of yield, it evaluate is an operator to pause and resume a generator function. Okay, hey, yield this string of data, and then go back to them when we call that again. But the yield is a way to how you say, hey, run and pause, run and pause, get into this function generator execution context, then get out, get in and get out, and get in and get out. So yield actually allow us to use this pause and resume operator. Okay. So it returns a new promise which will be resolved with the value returned by the async function, or rejected with an exception on caught within the async function. Async function can contain 0 or more await expression. Await expression make promise returning functions behave as though they are synchronous. Exactly. Async functions can contain 0 or more await, and await expression make promise returning function behave as though they are synchronous by suspending execution until returning promise. Exactly. So this is pretty much like yield from the generator. It suspend. You yield this, okay? And when that data is gone, when you get that data from the promise, all right. Or it is fulfilled or rejected. The result value of the promise is treated, and then return value of the await expression. Using async and await enables the use of the ordinary try and catch block around asynchronous code. Again, all of this awaits in keyword, so awaits behave like synchronous, like synchronous operations. Exactly. Await expression make promise returning function behave as though they are synchronous by suspending execution until the return is promised. Exactly. Behave like that. So the await keyword is only valid inside of the function. Exactly. The purpose of the async and await is to simplify the syntax necessary to consume promise-based API. The behavior of the async and await is similar to combining generators and promise. Again, it's similar to combine generators, how we're going to yield and pause the execution of this function. And when you call that again, all right, you're going to evaluate the next statement and get the data. Is a way how you can change that. So pretty much like when you're doing this generator or this async and await, it's like working with the promise, but when you now wants to subscribe, or when you want to actually capture, when this promise is resolved, okay, so when this promise is resolved, you're going to now trigger this next functions. Trigger is the generator as a way to evaluate that expression and then yield the data so we can get that. Holy moly, bro. So all of this inward and outward async functions all will return a promise. If the return value of an async function is not explicitly, a promise will be implicitly wrapped in a promise. For example, consider the following code. It is similar to this. Even though the return value of an async function behaves as if it is wrapped in a promise result, they are not equivalent. Even though the return value of an async function behaves as it is wrapped in the promise result, they're not equivalent. An async function will return different reference, whereas promise result return the same reference in the given value if a promise. It can be a problem when you want to check the equality of a promise and return value of an async function. Okay. Return P is equal to the basic return, which is basic return. Okay. Returning a promise and a basic return. Okay, promise is the same as a promise. Here, when you return is this promise? Yes, it is. But when you return a promise P, it's not. The body of an async function can be thought of being split by 0 or more await expression. Top level code up and including the first await expression if there is only one. Okay. To include the first await expression is run synchronously in this way. An async function without an await expression, it will run synchronously. If there is an await expression inside the function body, however, the async function will always complete asynchronous. Oh, because now this, exactly, as long as you run is something now, as long as you are returning an await, it will return is a promise base. Exactly. This is the same to return is a promise that is resolved with that. That's interesting. Go after each. Oh my God. So instead of actually you to writing is a promise base, So for example, instead of you to actually running is a promise resolve base, okay? So for example, async function, okay, async function resolve, where here you say, hey, let me now define as an async function that is going to await one. This is the same to say a promise function resolve as a promise, okay, as a promise resolve, promise dot resolve with one. Interesting. Console log async function resolve and console log promise resolve. Oh, but it needs to call that. Okay. The then undefined. Okay, it's because you have actually return is that value for them. But it is equivalent. Okay, it is equivalent. Code after each await expression can be thought as an existing of the dot then callback. In this way, a promise chain is progressively constructed with each retrain step through the function. Then return values form the final link in the chain. In the following example, we successively await two promise. Progress move through the function foo in three steps. In which way? The following example. Okay. The following example. Okay, because now the await keyword, what is doing? Okay, now we would take a look at the await keyword. Okay, it resolve, right? Wait for a promise and get it is fulfilled value. It will wait until it is fulfilled value. It evaluate that, but the expression must be attainable. It evaluate that. If you return a value, if you evaluate is a value, it's like you're returning that value. So here what it's doing is that I'm going to evaluate this new promise. Okay, on fulfill, what I'm gonna get is the one. The first line of the body of the foo is executed synchronously with the await expression configured with the pending promise. Exactly, the first line of the body foo is executed synchronously with the await expression. Configure with the pending promise. Progress through foo is then suspend and control is yield back to the function that call foo. Okay, progress through foo is then suspended and control is yield back to the function that call foo. Sometime later, when the first promise has either been fulfilled or rejected, control moves back into foo. The result of the first promise fulfillment, if it was not rejected, it returned from the await expression. Here's one is assigned to the result one. Progress continue and the second await expression is evaluated. Again, process through foo is suspended and control is yielded. Is suspended and control is yield. Sometimes later, when the second promise, which is now when the second promise has either been fulfilled and pass that to the micro task queue, is returning to from the second await expression, where now it's going to pass and evaluate that. What you get here at the resolve is now, this is wrapped into a promise, which is now going to pass that into the promise callback, into the micro task queue here. The default return value of undefined is returning as the resolution value of the current promise. Wait a single moment. Here's 2 is assigned to the result 2. Controls move to the return expression, if any, and the default return value of undefined is returning as the resolution value of the current promise. Note how the promise chain is not built up in one go. Instead, the promise chain is constructed in stage as control is successfully yield and returned to the async function. Okay, it's yield and return. The control, exactly. The control is successfully yield, generated, and generated from, and returning to the async function. The async function, the await keyword actually is the way of, it behaves somewhat similar to the yield. Okay, it yield this, and then we take control. Sometimes in the future when this promise is resolved. So when that promise is resolved, it passes that to the micro task queue. The event will evaluate that task, grab that, all of the tasks in the micro task, pass to the callback queue, to the call stack, and the call stack say, okay, this is what I need to evaluate. This is the function that I need to evaluate, which is this resolve one. And this is what I'm going to provide is to the .dang on resolve. We must be mindful of error handling behavior when dealing with concurring asynchronous operation. For example, in the following code, an unhandled promise rejection will be thrown. Do not do this. Use promise at all or promise all settle instead if you're going to actually handle all of this. To handle this concurrent async operation. Async function declaration behaves similar to functions declaration. They are hosted. Async function declaration behaves similar to functions declaration. They are hosted on top of their scope and can be called anywhere in the scope, and they can be redeclared only if certain contexts. Unlike class are not hosted, whereas async functions, yeah, they are. Interesting. Async functions and execution order. Resolve after 25 seconds. After 2 seconds. Async functions and execution order. Oh my god. Okay. Resolve after 2 seconds. You wrap that timer into a promise that you want to return as that you wrap that timer into a promise when it's resolved. Okay, you wrap this function. You wrap this function. Slow promise is done. So you wrap this function where now this is what is going to be returning. You're going to evaluate this. Okay, let's going to evaluate this. It's going to evaluate this function that'll be passed to the callback queue. Okay, where on fulfill a promise that is wrapped here on fulfill. Now you're going to first show this and then this. So start slow promise, start fast promise. Okay, return a new promise as well, resolve fast promise is done, and then you got this sequential start. Console log, it will be sequential star, sequential stars, sequential star stars. First, start a timer log after it is done. In this case, slow. And then you're going to wait for that. Second, start the next timer after waiting for the previous one. Exactly, because we are waiting for that. Start the next timer for that result after 1 second. Await fast, sequential start, and this is sequential wait. Sequential start is different, and sequential wait is different. So console log here, sequential wait start, start to promise without waiting for each other, like this. Slow result after 2 seconds, slow fast result after 1 second. Okay, and then 2, wait for the slow timer to complete. Exactly. Here you actually put them, you set those timers. Okay, you started 2 timers without waiting for each other, because the first is sequential, sequential start, sequential wait. Oh, these two concepts are actually interesting in the asynchronicity. Is sequential wait or is sequential start? Okay, is sequential evaluation or is sequential wait? Okay, which one of them resolve first? Okay, wait for the slow timer to complete and wait for the faster timer to complete and then log result. Sequential wait done. And this is now concurrent one start 2 timers concurrently and wait for both to complete. Exactly, because the promise that all is I'm gonna wait for all fulfillments or the first rejected. Exactly, and then log the result. And then you get concurrent 2 start 2 timers concurrently, log immediately after each one is done. You're going to wait for that, and because here you are passing is these promises. Okay, that those promises actually is an array of functions. Here you're actually saying is immediately invoke function expression. Okay, start 2 timers concurrently, log immediately after each one of the start 2 timers concurrently, log immediately after each one of it is done. So sequential start after 2 seconds, log slow, and then after 1 more second fast. Sequential start. The other is way about to finish. Sequential wait after 2 seconds, log slow, and then fast. Wait again, same as sequential wait, which is concurrent 1. You're gonna wait for all of those promises to complete. Alright, and then concurrent 2 is I'm going to now start those timers, log immediately after each one is done. Okay, then going to run. Okay, this is for concurring them. Which one of them resolve first? This one, and then this one. After 1 second log fast, then after 1 more second is slow. In sequential start, execution suspend 2 seconds for the first await, and then another second for the second await. The second timer is not created until the first has already fired, so the code finish after 3 seconds. In sequential wait, both timers are created and then awaited. Exactly. In sequential wait, both timers are created and then awaited. The timer runs concurrently, which means the code finish in 2 rather than 3 seconds. In the case of sequential wait, both timers are created and then awaited. The time runs concurrently, which means the code finish in 2 rather than 3 seconds. Exactly. With this sequential, you have to wait for the first timer to be completed, and then you're gonna wait for the another. So 1 plus 3, sequential, start sequential. But when you say wait for that, is sequential wait. Okay, so the first with sequential wait, using the promise with sequential wait like this, is that resolve the first one and then the other one. After sequential wait, interesting. Sequential wait. After 2 seconds, log slow and then fast. Sequential wait. One of them is sequential start, okay, and the other is sequential wait. Okay, sequential start and sequential wait. That's quite interesting. Yeah, that's quite interesting. That's very, 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 very interesting. By the way. Okay. Oh. Interesting. So sequential wait and sequential start. But the sequential start is with the await, and then define the another one. You know? And wait for that. So stop the execution until you get that, and then reassume that start sequential or sequential wait. Sequential start. And then the other is sequential wait. So run both timer, run both async tasks, and then you're going to wait for the slowest one here, and then the fast, which will take is now this is sequential wait. And then when you want to do concurrent, you use the promise.all, okay, concurrent one, where the promise.all say, hey, wait for all fulfillments, or the first to, wait for all fulfillments, or the first to, Jesus, wait for all fulfillments, okay, wait for all fulfillments, or the first to, or the first rejection. Wait for all fulfillments or the first rejections. Okay. That's interesting. That's powerful. Okay, the promise.all. Log the result together. And again, this promise.all, if you want to do tasks that depend one after the another, okay? and the other is now concurrent to, which is start two timers concurrently and log immediately after each one is done, pretty much like a race. Okay, hey, I want you to run this, and I want you to run that, and then give it to me, and then give it to me as they are resolved. After 1 second, log fast, and after 1 more second, slow. But because you are doing here is the promise here. It's because here you are doing is the promise. It's because here you are doing is the promise here. And then when you said, hey, timers, this for such function, this for such function, I want you to now is run the concurrent reference, or this callback. I'm going to inject this callback here, and then after 10 milliseconds, okay, what I want now to run is this after 2 milliseconds, or 2000 milliseconds, which is 2 seconds, and then you got it. It's a concurrent, of course, because the result after that is not defined. Is this? It's both of these functions. So what you're doing here is now is effectively running those functions. That's pretty interesting here, because you're saying is that, hey, promise.all, I want you to now run this function immediately. Async, this is an async function that I want you to now console log is the returned value of this promise operation, which is the resolve after 2 seconds. Okay, I want you to now console log that and invoke that at once. So when you are now enter here and evaluate this, okay, you are saying, hey, Jill, this promise all as a way to now run this first async function immediately, which I want you to log is the response of that. Holy moly. And then do this. Holy moly. Star slow promise, star fast promise. Fast promise is done. The star slow promise, star fast promise, exactly. And then the first one is being resolved. The concurrent two, because that's all we are now is running this. We are now invoking is this async operations concurrently. We're running into these concurring operations. All right, starting fast and promise. Fast promise is done. Fast, it give you is the value of that fast, and then slow promise is done. Slow and concurring is done. This is how you can now handle is a concurrency, await and concurrency. The function section wait and concurrency one are not correctly equivalent. Exactly, the sequential wait and the concurrent one are not functionally equivalent. In sequential wait, if a promise fast reject before promise slow is fulfilled, then the unhandled promise rejections error will be raised, regardless of whether the caller has configured as a catch clause. In concurring one promise at all, wires up the promise chain in one go, meaning that the operation will fail fast regardless of the ordering of rejection of the promise, and the error will always occur within the configured promise chain, enabling it to caught in the normal way. Rewriting a promise chain with async function. Exactly. But here we're doing this sequentially. Makes sense. If we want to perform concurrent, we use a promise at all and that. Promise at all and the async functions we want to run. Alternative, you can change the promise with the catch here. Okay. In the two rewriting versions, notice that there is no await statement after the return keyword. Although that will be valid too, the return value of the async function is implicitly wrapped in a promise resolve. If it's not already a promise itself, as an example. God damn.
We are going to encounter what line next? Blessing.
Console.log me second.
Me second, exactly. At about, let's say maybe 2 milliseconds, something like that. About 2 minutes. In other words, the most important thing we wanted to do with any asynchronous work is set up a task that takes a bunch of time. That's the web browser feature task to speak to the internet. So it takes 200 milliseconds. Set it up, but be able to continue running our synchronous code afterwards. But now do we see, to do it, we're stepping out of our function. And wouldn't it be wonderful if we could step back in to our function to when we get the value from the request back as a response, hopefully it's going to be stored in data, and we can then continue running our code and log that data. Wouldn't that be wonderful? Let's hope it is possible. So in JavaScript now, we don't really have much interesting stuff to do. We're done. We're done. But there's our call stack. But in the background, after about 200 milliseconds, interesting stuff is happening. About 200 milliseconds later, memory, we are going to trigger, and we can think of in our on-fulfillment array as effectively the context, and at about 201 milliseconds, re-enter, where we effectively paused. We're going to get to re-enter, add create flow back on our call stack, and come back in. And the await fetch, await was super powerful. It threw us straight out. We never even got to assign anything to data. That's not a bad thing. We're hoping that data is going to be filled in with whatever this right-hand side evaluates to. And what does it evaluate to, Blessing?
Hi.
To the value from the request of the internet that came back with hi.
We request a come
That is what
came
our
back.
await expression evaluates to, hi. And we assign it to what?
And again, because exactly await is now evaluating. Await is evaluating. Await is used to wait for a promise. Okay. Await is used to wait for a promise. So if you're not return is a promise, for example, a number, then what you effectively are doing is to create, is like saying promise.resolve with the value 1, and now run the dot then as it is, as the call is handling reject promise like this, as the call is here top level away, control flow, improving stack trace, Okay. But the await operator is used to wait for a promise and get its fulfilled value. It can only be used instead of an async function or a top level of a model. So again, the await, what it's going to evaluate is a promise. It's a promise and get its fulfillment value. Okay, that's what the await is going to do. It's going to evaluate a promise object. It's going to evaluate. It's going to wait for a promise and get its fulfillment value. That's what it's going to do. The await. You can think of this kind of the yield, where yield is now saying, I'm going to now produce this. Exactly. So it's kind of like I'm going to produce this when you run this function, this generator function. And in the case of async, it's like when I see the await keyword followed by an await inside of that, when I see that, I'm going to wait for the promise, and gets its fulfillment value for that. It's like pause the execution until I get its fulfillment value. Who is actually managing is that waiting operation until they get the fulfillment value? It's actually the host. It's actually when you're using the promise. So when that promise is resolved, whether you're using a set timeout or a network operation like fetch, those actually are the responsible to say, hey, this is the this promise was resolved or rejected. They are the one who actually notify us there, and that is by updating the value. And then when you update the value, it will trigger on the promise object. It will trigger is, if it is resolved, the dot then callback, or if it is rejected, the dot catch callbacks.
Label to data. And so we hit our next line in the body of our create flow function. Console log data. Data is going to be evaluated to high, and look at that. At about 202 milliseconds, we get to continue running the rest of our code. We get to continue running the rest of our code inside our create flow function. All that work of returning a value, the response object that we saw before, into the promise object that we stored in future data, that we then triggered a do when data receive function, that then triggered .next on the return next element call, or return next element object next function that triggered us to go back into create flow. All of that automated. The async function definition is going to handle all of that for us. The await still behaves similar to a yield. That we're going to hold on storing anything on the left-hand side until we get something back from this background work. But now when the value comes back, we're just going to go straight back into create flow and store it.
Exactly. So when the value when the value comes back, we're going to straight evaluate it.
Beautifully cleaned up version of that highly complex setup we had that was nevertheless a very powerful setup, but now we have a cleaned up version. And by the way, this cleaned up version behind the scenes is doing all of this. So if you want to emulate the async await function definition and call, we can do it ourselves with generators. And this is the senior dev interview question of the next few years. This sort of under-the-hood understanding of JavaScript is the foundation of getting a senior developer position, or a mid-level developer position. It's also deeply satisfying. So I run Codesmith, a community of people building compelling open source projects, whether it's Reactide, an IDE for React, whether it's a remarkable Kubernetes tool that was developed.
So that'll be all for this video. Take care. Bye-bye.